Hi, welcome to another episode of the Manufacturers Make Strides podcast. I'm your host, Martin Griffiths, and today I'm interviewing Tony Day. Tony is head of mechanical engineering at Kingdom Technologies, where over the last 2 years, he's been using a lean manufacturing approach to produce design iterations of autonomous robots. Kingdom Technologies is one of the fastest growing startups in Scotland, and their autonomous robotic lawnmowers are used by golf clubs, city councils, and universities. So let's get right into it now and see what we can learn from Tony. Hey Tony, afternoon. How are you doing?
Yeah, hello Martin. Not too bad. Yourself?
Brilliant. Yeah, really good. Thanks. Thanks for joining me on the podcast today. Really excited to dig into some of your history and what you're doing at the moment. So just wanted to start really. From what I've read, you're really passionate about engineering. How did that come about, and how did you end up getting involved in engineering?
Yes, it's kind of a family thing, really. So my dad used to work away quite a lot in the week. So when I was a kid growing up, I only used to see him on the weekends, and it meant that he would come home and have lots of things to do. He's quite good at, he's like into DIY and kind of fixing things up and stuff like that. So my experience when I was younger, kind of with my dad, was getting involved with, repairing, the car, or, making something, fixing something around the house, that kind of stuff. So I'd always be following him around, like picking up his tools and doing that sort of thing. So it was kind of a bit of a hands-on, how things are built and how to fix things and that kind of that stuff. So that's kind of where it, that was the seed. And then from there, as I kind of grew up and started to do things myself, getting a car, having to get my own, you get to kind of 17, you're going to get a car, and you kind of think, oh yeah, I'll get something, I can like do it up. And that was my mindset anyway. So, I did a lot of work on, I bought an old Land Rover, and ended up taking everything off and seeing how it always works, and then put it back together again. And sometimes it worked again, and sometimes it didn't. And you had to kind of go through that. So I think that's where it all kind of stemmed from, was that kind of, me spending time with my dad and that kind of relationship, and then that kind of blossoming out of that.
Yeah, great. So it seems it's taken you on quite a journey through kind of different companies and all sorts of interesting products. At the moment, you're creating autonomous robots with Kingdom Technologies. So can you tell a little bit more about those robots and what they do and what the idea is behind that?
Yeah, so robot lawnmowers, nothing new there. They've been around for a few years now. So the ones that you typically find, if you do see them, are for small kind of homeowners. They cut small lawns. The idea with them is that you install usually a boundary cable around the edge of the lawn, and that's how it knows where to cut. So as far as the robot is concerned, it just goes out, and as soon as it senses this cable that's been laid in the lawn, it goes, oh, that's the edge, and it'll turn and drive off. And it's just random, so it just randomly bounces across the lawn, and eventually it will cover all of the lawn. But it doesn't do it any particular order, it just randomly moves around. So we're taking our product is designed for larger landscapes, right? We're talking about doing larger areas of grass. And one of the ways that we do this is by navigating more intelligently. So the robot plans a path around the lawn so that it covers only each area, each part of the lawn once as it goes over. The other thing that it does is it doesn't need this boundary cable, because if you about doing 50,000 square meters of lawn, you're not going to want to have somebody go around and lay a boundary cable around the edge. So we've got rid of that by using GPS, and we have an app that you can use that you can draw out the boundary that you want to cut the grass off, and you can do dynamic changes if you want on the fly. So that's where we kind of differ from the current products that are out there. We're using our robot to do large areas, so we're more targeting kind of B2B, going to commercial customers.
I see, yeah. So I imagine it must be really inefficient, the kind of the the ones for your garden where it just bounces about randomly, basically. You must be covering a lot of ground kind of multiple times, I imagine.
Yeah.
So,
yeah, you might cover one patch. You might cover one patch 10 times, and you might cover another once. Like and it gets difficult if if you've got a square lawn, then it's quite easy for it to bounce around. But if you've got a little kind of nook round the corner of a tree or something like that, it can get stuck in an area because it just bounces around. Like if you dropped a ping pong ball, it'll just bounce around in that corner, and it'll never be able to get out. So that's another disadvantage of it.
Okay, so what's your process then for developing and manufacturing the robots that you've made?
Yeah, so we have kind of, ever since I've joined the company and been here, we've been using a slightly different technique to what I would call traditional manufacturing, where and development, where you would have a prototype. You'd have a prototype and you do lots of tests in isolation, and you'd build up this prototype, and then you test the prototype. And once that's got to a point where you're like, oh, I'm happy with this, you'll then move on to some form of series production, whether it's even a small run of 10 or something like that. That's how you do it. Whereas what we tend to do is we create a design change from what was the original robot that we had, which you could kind of compare to a prototype, but it wasn't final. Like, it's not the final product, it's just a first attempt, and then we iterate through. So we will then make changes to that, we'll produce a number of them, and then we'll put them out into the field and we'll see how they do. And then we get feedback from that, and they'll go out to customers as well. Now it's not a finished product, so it doesn't go out to a customer with the intent of being, oh yeah, it's done and it'll do everything you want. We have customers that we've spoken to and say, right, this, we're in a development phase, you're going to get a kind of beta test kind of product, and here it is, and then you can use it, and then we get feedback from that, and then we make those changes quite quickly. So we would look to turn changes around, even from a hardware point of view, in months, which is quite challenging. It's quite difficult, because you're trying to, the manufacturing process might take 6 weeks or so to get all of the parts, just that on its own, let alone thinking of designing in all the changes and getting them all produced and all that kind of coming out. So it's quite fast paced, but the idea is that you shouldn't be making huge changes. They should be small incremental changes where you're just optimizing what was the original design. Every now and then that doesn't work, and you have to do a big change, and maybe that takes longer, and you do have some kind of prototype testing and things like that. But the idea is to get as much as you can into the next iteration of robot, send it out into the field, and then you're kind of using you're using those robots that are in the field, and with customers, you're using them as your development robots as well as while they're kind of bringing in revenue. So that's the idea behind it.
That's really interesting. It's similar. It brings to mind like kind of agile software development, really, and kind of starting with a minimal viable product and then having a series of sprints to add features to it while it's out there. And you're always getting quality feedback from your, live feedback from your customers, aren't you? So that's really interesting. Is that where you started off, trying to replicate that method? Yeah.
So when the company was started, that was the intent. The intent was to run it agile, and it still is. We still have discussions about that. I think the thing that we've learned is that you have to make exceptions for hardware. Like you cannot run the manufacturing process for hardware in the same way that you would treat software. You can't do it. There are limitations that you need to understand. So from that, we have tweaked it slightly so that there is a kind of, we do have prototypes, we do run tests that we're not completely relying on the customer, the final product that goes out, to get all of our test data from. We do have, test benches where we test all of the different kind of parts of the robot in isolation, and we get feedback from that, that we then use before we send it out. So you've got to, it's not as clear cut as just being like, oh yeah, come up with an idea in my head, design it, build it, and then send it out and hope that it works. Like it's not like that. But it's just understanding that. I think originally the idea was that was the kind of, if we can run it like this, it will be great because we won't have to have any development work going on on site. We can just send it all out. But I think that was quickly realized to not work for hardware. So
okay. So what are some of the major challenges that have come up adopting this process, and have you gone about overcoming them?
I think one of the big things is if you have a big problem, like if there's a hardware issue that you didn't foresee and you didn't pick it up in the initial testing that you did, but then you've developed, let's say you've made 10 robots and you've sent those out. Well, you've now got 10 robots that you have this issue with, and if it's something that's big, you need to do something in order to fix all of them. You haven't just got one prototype that you go, that didn't work. Let's just change that, and you just have to fix the one. You've got 10 out there, so you have to come up with a fix and a repair. We also don't have all of our robots that are close to our main site, so we have retailers. So we then have to kind of come up with a pack that we would send to them, and they have to fix it. So that is something that you wouldn't normally have to worry about so much when you've got complete control over the product, because it's a prototype that's sitting in your workshop. And you can just go in there and be like, okay, this hasn't gone right, let's try something else. Whereas I have to build up something that I can send out to somebody else for them to do the repair. So it has to be well documented, and that adds time to a bit to the process. So those are the ones that they're the tricky points where something has gone wrong, and something's been overlooked, and you have a failure that's it could be anything. The other thing is, because we're manufacturing quite low volumes, but the intent obviously for the product in the future is to be producing large quantities of them. So we don't want to change too much how the robot looks, and from as we go through the different stages of being able to use different manufacturing methods. So that means that what we're using at the minute, it's kind of prototype plastics, and so it's CNC'd plastics, and because they have their own problems that you wouldn't see once you get to injection molding. But so there's things that we've had to do where we've had to reinforce certain areas of the robot with maybe some metal plates and things like that, which we'll lose once we get to a point where we're at high volumes. But they're the other areas where we've had to tweak it a little bit just to make sure that we get these kind of things that they're only a problem while we're in low volume. And as soon as we move our way up, and you have to kind of change, and that adds a little bit of extra time as well, because every time we if we do a batch of 10 and then maybe we think, actually we're a bit more confident now, we'll do a batch of 20, we might want to change some of the manufacturing processes for that jump in quantity, and then we have to rethink, hang on, did those changes that we made for the initial 10, are they still valid? Do we still need to do that, or can we get away with maybe removing some of those plates because now the manufacturing process that we're using is better for the structure of the product? So that's things that we think about as we go through each iteration as well.
So it definitely kind of inspires your creativity, I suppose, to come up with solutions to that all the time. So I suppose looking back now, what do you think are the kind of the big benefits or the big pros to this method of product development and manufacturing, for this kind of stage of a product versus a more traditional method?
From an engineering side, I think you get a lot of real world testing in, because rather than having one prototype that you might be testing at your test site that is meant to be representative but not always is, You've got multiples that are out at customer sites doing the job that you want them to do. So you are getting real world test data back, and when you get a failure, you know, you're seeing a real failure. You can guarantee, you go, that actually happened on a site while it was working. So it's not, you don't have to think too much about, or hang on, were we testing it correctly? Did we slightly overwork it? Have we done something? And because you've got several of them out there, you get your kind of statistical data out of it as well. You know, if you've got 20 robots that are out there, you can say, oh, hang on, one of these failed in this particular part, but it's only one. We've only seen one of the 20 that have had this failure, and all the others have been fine. So you can understand a little bit more about whether that was a bit of an anomaly, or whether you are actually dealing with an issue. And if you see all, you know, if you get like 19 out of them have this failure, then yeah, right, well, that's definitely a problem. We need to fix it. So you can kind of look at those numbers. The other side is from the business side, which is that we get to test out the kind of the plan. You know, you get to test out whether this is a viable business, whether people are willing to pay money to have this product, whether they're happy with the product. You get all this feedback from the business side, making sure that what we're leading up to is going to be, you know, worth it. So that's kind of from the business side. Which is a huge thing. Like if we spent all of our time working on the product in isolation and just asking customers whether it's what they want, but without really giving them an example, you might, you know, end up designing the wrong thing. You might get the wrong wrong feedback from the customer, and then you go, oh, hang on, well, we've designed this for you, and then they turn around, oh, that's not what I wanted. Whereas now we get that's not what we wanted while we're developing it, because they get to see the product and they see what our intent is, and then we can adapt. You know, we're at a stage where if the customer turns around and says, oh, well, I thought it was going to do this, I thought it was going to follow this edge better than this, and you can turn around, okay, no, that's fair enough, you've said that, we'll take that feedback on board and we can adapt that in.
That's an interesting point. How do you manage that feedback? Because I suppose your goal is to create a product, you know, that will, you know, address like a broad range of customers. I suppose one of the challenges with getting very specific feedback like that is that you maybe weight it too much to the loudest customers, basically. So yeah, how have you handled that?
So every time we get feedback in, we kind of we don't just take it as the raw feedback and say, and if you get one comment from one particular customer, you're not going to then immediately jump on it and make that change. You know, if they wanted it to be painted a different color, you're not going to immediately go, right, paint all the robots this color because this one customer wanted this change. It's that kind of, you know, you're going to look at it from a point of, oh, how many customers have asked for this, and what comments are they saying, and are they saying it's a huge problem that they're struggling with, or is it just something that, oh, you know, I'd like to have it do this, but and a lot of the time you have to question it back to the original goals of this first robot that we're producing. You know, is it encompassed within, is it what we want this robot to achieve, or are they actually asking for an additional feature that maybe we can think about in the future and we don't need to worry about in this way? So we do have to kind of decode the customer feedback and make it into workable. So some of them go into features straight away. So some of them you get feedback, you might get it from several customers, and you'll instantly say, right, the next iteration, we need to make sure we work that in, because it's something that everybody wants. And if it's relatively easy to implement as well, then you can get it in quite quickly. And if it's something that's much harder, then maybe you put it on a longer timeline and you think about it will be introduced in kind of a few months rather than straight away. So yeah.
I see. Yeah, makes sense. So it sounds really, really interesting. It sounds kind of a fascinating kind of area that you're getting involved in. What are the goals of Kingdom Technologies over the next few years? You know, where do you see the company going? And
yeah, so I mean, we've got we've got it kind of laid out for the next kind of 18 months up to Series A, essentially. So the idea is to get this design of robot up to Series A, and then it's just a case of all the designs are frozen, and we can order as many as we want on a month by month basis. So we'll order them as we need them for customers. So on that journey, there's a lot to do. We need to do a lot of work just purely on how the robot functions and how it handles the day-to-day tasks and all that side of things, as well as making sure we get everything right through the compliance, so get CE marked, all those type of things. And a lot of that will be making sure that our manufacturing kind of partners are capable of handling the volumes that we're talking about once, because the people that we deal with now, we're talking about making prototypes. So we're talking the people that manufacture our product currently, we're talking about double-digit numbers, whereas soon we'll be into the hundreds, and then after that we'll be even more every year. So we need to manage that as we go through as well. So there's a lot of work to do just purely from the manufacturing side of things, as well as freezing the design, making sure that it's compliant and it's signed off against all the correct safety standards, and that sort of thing. So there's a lot of work to do in those, and we've planned that out over the next 18 months to get to this Series A point where we can start to produce the robot just as and when we need.
Yeah, brilliant. So there's all that work to do. Are you looking to kind of bring some people on board to help you get there and reach those goals?
Yes, we very much are. We're actively hiring at the minute, and we will continue to do so through that entire period. We need people for all areas. So we have software hires out, we have hardware hires for electronics and PCB design, and as well as the mechanical side of things. So we're looking at, and then outside of the engineering, we're also hiring, just things like that. So it's all available on our website. If you go to www.kingdom.garden, you can look on there. We've got a careers page, and there's loads of stuff. So if anyone is listening and they feel like a career change, then make your way over there and have a look.
Yeah, brilliant. Sounds great. Yeah, we'll post a link to that in the description. Yeah, that's great. Well, thanks a lot for your time today. That sounds kind of fascinating. What you've told us, the link to the website, that's great. What's the best way for people to get in touch with you if they want to ask a question or send a message?
So LinkedIn's the best, probably to get in contact with myself directly. My LinkedIn is LinkedIn/in/Tony Day 90 is great. Myself. So
perfect. Well, thanks very much, Tony. Really appreciate your time today. Great to hear more about what you're doing and about your kind of really interesting process that you've developed. Yeah, I really appreciate that. Thanks a lot.
Thank you as well, Martin. Thank you.
Cheers.